Bayesian inference introduction. Bayesian inference is a specific way to learn from data that is heavily used in statistics for data analysis. Bayesian inference is used less often in the field of machine learning, but it offers an elegant framework to understand what learning actually is. Bayesian inference is a way of making statistical inference in which the statistician assigns subjective probabilities to the distribution that could generate the data. These subjective probabilities form the so-called prior distribution. After the data is observed, Bayes' rule is used to update the prior, that is, to revise the probabilities assigned to the possible data generating distribution. These revised probabilities form the so-called posterior end distribution.
The importance of Bayesian inference. Bayesian inference is an important statistical method that allows us to update our beliefs about a hypothesis in light of new evidence. Unlike classical statistical inference, which relies on p-values and null hypothesis testing, Bayesian inference provides a more intuitive and flexible framework for modeling uncertainty and making probabilistic statements about our data. One of the key benefits of Bayesian inference is that it allows us to incorporate prior knowledge or beliefs into our statistical models. So meaning that Bayesian inference allows us to explicitly incorporate prior knowledge or beliefs into our analysis. This means that we can take into account what we already know about the hypothesis or parameter of interest before observing any data. So this can be particularly useful in situations where we have limited data or where the data are noisy or ambiguous. By incorporating prior knowledge into our analysis, we can often make more accurate and informative inferences. So another important feature of Bayesian inference is that it provides a natural way to handle complex models and hierarchical structures. So, meaning in Bayesian inference, it provides a powerful framework for handling complex models and hierarchical structures. So, in many real world applications, the underlying mechanisms that generate the observed data are often complex and not fully understood. So, Bayesian inference allows us to build models that capture this complexity and uncertainty, and then use the observed data to update our beliefs about the model parameters. Bayesian inference can be used in a wide range of applications, from finance and economics to biology and engineering, by providing a unified framework for modeling uncertainty and making probabilistic statements about our data. Bayesian inference has become an increasingly important tool for modern data analysis and decision making. So, for example, in finance and economics, Bayesian inference can be used to model financial data and make predictions about future trends or outcomes. For example, it can be used to estimate the probability of a particular stock price increase or decrease, or to forecast the future performance of a portfolio of investments.
Real-life example of Bayesian inference. If we know that planets revolve around the star because we have observed this in the past, and we know that the most stars have planets orbiting them, then we can use Bayes' theorem to predict that new stars will likely also have planets orbiting them because they were true of stars thus far.
Application of Bayesian inference. Bayesian inference is an important technique in statistics, and especially in mathematical statistics. Bayesian updating is particularly important in the dynamic analysis of a sequence of data. Bayesian inference has found application in a wide range of activities, including science, engineering, philosophy, medicine, sport, and law.